In this video, we are going to learn about reference angles. We're going to start by defining them, and then we're going to see what they look like. So right here it says the reference angle of a given angle is the positive acute angle formed by the terminal side of the angle and the x-axis. Now, that's kind of a mouthful. We're about to visualize and see what that actually looks like. And I'm going to use this applet for it. I found this GeoGebra applet that I think is really helpful, and I'll put the link to it in the show notes. And so right here, we have shown in blue a standard angle and in red the reference angle. So here in the first quadrant, you can see that the angle is the same as the reference angle. But as I move into the second quadrant, if we had a 130-degree angle, the reference angle is right here. It's kind of like the supplement to 130, because the reference angle is the angle created by coming straight down to the x-axis, creating an acute angle. You could kind of guess what happens here in the third quadrant. If I had a 200-degree angle in standard position, the reference angle would be 20 degrees. Because if I create the acute angle by coming up to that x-axis, this angle right here is a positive 20 degrees. And then we could use some similar reasoning for the fourth quadrant. If I have an angle in standard position that's 300 degrees, I would just come straight up to the x-axis, and I know that if this is 300, then what's left over must be 60 degrees. So this would be, so the way we'd say this is a 300-degree angle in standard position has a reference angle of 60 degrees. Now, we have all these definitions right here, or actually these formulas. And so you might be a formula person. For this particular idea, I prefer to not use formulas. I think it's easier just to visualize it. And so I'll show you what I mean by that. If we're right here, we know that in the first quadrant, if your angle is between 0 and 90, the reference angle is just the same as the given angle. And we can see that right here. If I have a 61-degree angle, then our reference angle is 61 degrees. If I have a 35-degree angle, then the reference angle is 35 degrees. Now, if we pivot into the second quadrant, let's get some nice round numbers. How about 120 and 60? So if I have a reference angle in between 90 and 180, that means, or excuse me, if I have an angle in standard position in between 90 and 180, that means it's in the second quadrant. Mathematically, our way to find the reference angle is to do 180 minus that angle. Now, if I look over here, you can memorize that rule, or we can just look and see, oh, my angle in standard position gets to 120. I know I come straight down to get the reference angle, so that means my reference angle must be the 60 degrees we have left. I think of it that way. You may prefer the formula. I don't know. Now, let's look in the third quadrant. Let's do, how about 35? Oh, bam, there it is. So if we have an angle of 215 degrees in standard position, you could memorize this rule that I just do my angle minus 180, or I could just kind of visualize it. I think, okay, I went 215 degrees. That means I went 35 degrees past halfway, past that 180 degree mark. So that means my reference angle must be these 35 degrees that I have left. And then we can go to the fourth quadrant and kind of use similar reasoning. If I did 295 degrees from standard position, that means there's 65 degrees left to get back up to the x-axis, back to 360. So you could just think, oh, that's 360 minus my angle, 360 minus 295, or you could just kind of think about it visually. Now, with each of these, I've given the corresponding formula for radians. The only difference is that anytime you see 180 degrees, you'd replace that with pi radians. Anytime you see 360 degrees, you'd replace that with 2 pi radians. Now, one slide of examples and then we'll be done. So if I look at this first one, we're going to graph an angle in standard position. It's at negative 120 degrees. So if I'm doing negative angle, that means we're going in the counterclockwise direction. That means we go 90 degrees and then another 30. And I think I said counterclockwise, but I meant clockwise. A negative angle means you go clockwise. So here for me, instead of worrying about the formula, I always think of it as what's left here. If I come straight up to the x-axis, 120 degrees are taken up by this angle. I need another 60. I need another 60 degrees right there. And so that's what my reference angle is going to be. I'll call it alpha. We'll say alpha, my reference angle here is 60 degrees. Also note that even though my original angle in standard position was negative, I always consider my reference angle positive. Next, we'll do 3 pi over 4. Now, you might be fluent with radians, you might not. So for this one, if you want to just convert it to radians right off the bat, or excuse me, to degrees right off the bat, you can. But 3 pi over 4 is right there. It's the equivalent of 135 degrees. Okay? But it's 3 pi over 4, so you could memorize the rule and know that we do pi pi radians minus 3/4 pi. Or, if I'm kind of fluent with these radians, I know that, there's pi over 4 left. So you got pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. But if you want to do it mathematically, you do pi radians minus 3 pi over 4. And once you actually got a common denominator and subtracted those, you would get our reference angle of pi over 4. That's our alpha. That's our reference angle for this one. This last example is very simple, but there's a very common misconception that might bite you on a problem like this. So if I do 271 degrees from standard position, that means I'm going 90, 180, 270, and just barely past that at 271. I'm going to draw my angle right there. So there is our 271 degree angle in standard position, and we want to identify the reference angle. Here's where you got to be careful. Every temptation in you is going to want to draw your reference angle right here, over to the y-axis. Since we went 1 degree past the y-axis, you're going to want to say your reference angle is 1 degree. That is not how we defined reference angle. For a reference angle, we go up to the x-axis. This is our reference angle, which is not 1 degree. It's the 89 degrees that you need to get back to 360. So be really careful there. On some of these angles that are really close to the y-axis, you're going to be tempted to draw your reference angle over to the y-axis. Don't do that. It's always up to the x-axis, and it's always positive. And that's all you need to know about reference angles.